This is a very unusual looking problem. Previously we've talked about how we can do problems that have a fraction exponent whenever the numerator of that exponent is 1. For example, 81 to the 1/4 power is a problem we know how to do. That's just the 4th root of 81, or 81 to the 1/9 power. That'd just be the 9th root of 81. But 81 to the 3/4 power looks a little unusual. And before we talk about how to do this problem, I want to give you a little device that I use to remember this. This is a true story. I use this myself to remember how to do these problems. I want you to think about a tree. I'm going to give you some sweet math art right here. Here's my beautiful tree. And of course, like all trees, it's got a system of roots down here at the bottom. The roots of the tree underground. Down there at the bottom. And of course, above the tree, the thing that keeps the tree growing. Remember, you were in elementary school, and this is how you drew the sun on every paper. Was that just me that drew the sun as like a little quarter circle up in the corner of the page? Here's the sun, and the sun is beaming down on this tree, and the sun is where the tree gets its power. This is a true story. This is actually how I remember how to do these problems, is that whenever you're thinking about this tree, the roots are on the bottom, and the power comes from the top. Roots on the bottom, power from the top. So when I look at this expression here, this number with a fraction exponent, I think that the power is on the top, which is the 3. The 3 is the power, and the 4 on the bottom is the root. True story. That is actually how I remember this. So whenever I'm trying to simplify this equation, when I want to write this equation out so that it is, instead of having a fraction exponent, it has a root. It is the 4th root of 81 to the 3rd power. And that is for real how I remember how to write these as a root, as the 4th root of 81 to the 3rd power. So I think a very valid question to ask in this case would be, why in the world would you want to do that? What did we gain by doing that, by writing it this way? How did we improve this problem? And believe it or not, we did kind of improve this problem, because 81 to the 3/4 power, I don't know what to do with that. I don't even know how to rewrite that or anything except as a square root. But once it's as a square root, we can start doing some magic with this one. We can start doing some kind of interesting things maybe with this problem. And by interesting, I mean simplify. We might be able to simplify this problem. And so 81 to the 3rd power is 81 times 81 times 81. I don't know if that's hugely helpful to us since we're taking the 4th root. Man, if this was the 4th root of 81 to the 4th, boy, we'd be set, wouldn't we? But it's 81 to the 3rd. That makes it a little more challenging. But let's see if we can simplify this a bit. For example, I know that 81 is 9 squared. 81 is 9 squared. So I'm going to rewrite this as 9 squared to the 3rd power. And of course, that's really equal to 2 times 3 is 6, so this is equal to 9 to the 6th power. 9 to the 6th power, not too bad. We've made it a little simpler, I guess. I also know that 9 is 3 squared, so I can rewrite this as the 4th root of 3 squared to the 6th power. And 3 squared to the 6th power, well, 2 times 6 is 12. Using our exponent rules. 2 times 6 is 12, so this is 3 to the 12th power. 3 to the 12th power, not too bad. Now I'm starting to get excited when I look at this, because I see that I've got a 4th root, and I've got a 12th power, a 12th exponent here inside the radical sign, and I know that 12 and 4 will divide really nicely. So now that I've got it simplified like this, I'm going to turn it back into an exponent, just like I had right up here at the beginning, 81 to the 3/4. So I'm going to turn this back into an exponent. Now remember, this is going to have a base of 3, but the exponent will be power over root, just like our tree. Power on top, root on the bottom. So the root is 4. It's the 4th root of 3 to the 12th power. So power on top and root on the bottom. And 12 over 4 will reduce. 12 divided by 4 is 3. So this will reduce to 3 cubed, which is 27. 3 cubed is 27. So the answer, what is 81 to the 3/4 power? The answer to this problem is 27. So by converting it into a radical, doing some work with it, and then converting it back into a fraction, we were able to solve this problem without the use of a calculator. Now, of course, if you have a fancy graphing calculator, you can plug this straight into your fancy graphing calculator, like a TI graphing calculator, to do this problem for you, but we don't have a TI graphing calculator handy. And so this is a really kind of simple way, I guess, to do this problem without the use of a calculator. Okay, so let's try one that has a variable in it. Let's try 32 x to the 5th to the 2/5 power. Now, if you remember your exponent rules, you will remember that if we have two different things inside parentheses, both things in the parentheses get this exponent of 2/5. So I can rewrite this as 32 to the 2/5 power times x to the 5th to the 2/5 power. And that works out pretty nice, really, at least this part does, x to the 5th to the 2/5. Let's leave the 32 to the 2/5 alone for now. I'll go ahead and drop the parentheses because we don't need those. But x to the 5th to the 2/5, this is a base with an exponent raised to another exponent. This is a power of a power, so it follows that exponent rule, power of a power. 5 times 2/5 is 2. So this is x squared. When you multiply the exponents, 5 times 2/5, you get 2, so it's going to be x squared. So whatever my answer ends up being, it's going to be some number, whatever number this turns out to be, with an x squared on it. So I'm going to remember this x squared. Of course, I'm not done yet, I don't think, because I'm pretty sure this can be simplified. We'll see. But I'm going to remember this x squared. I'm going to put a little arrow here, and don't forget about this x squared. And the reason I'm writing this is because I'm not going to put the x squared in there until the answer. I'm going to figure out what 32 to the 2/5 is. I'm going to concentrate just on 32 to the 2/5. But I want to make sure when I get ready to write my answer that I don't forget my answer is going to have an x squared tacked onto it. So let's look just at 32 to the 2/5 power. And this can be rewritten as a root. Remember, power on top, root on bottom. So it's going to be a 5th root of 32 squared. Root on the bottom, power on the top, just like our tree. So there we go. The 5th root of 32 squared. So let's see if we can simplify this a little bit. 32 is base 2, I'm sure. Let's see if we can do this. 5th root of 32 is, let's break this down over here because I'm not really sure off the top of my head. 32 is 16 times 2. That's 4 times 4, that's 2 times 2, and that's 2 times 2. So 32 is 2 times 2 times 2 times 2 times 2. It's 2 to the 5th power is what 32 is. So this is 2 to the 5th power squared. 32 is 2 to the 5th power squared. And now we've got power of a power. 5 times 2 is 10. So this equals the 5th root of 2 to the 10th power. And now I'm kind of excited again because I see that I've got a root of 5 and a power of 10. And I know 10 and 5 will divide into each other very nicely. So I'm going to put this back as an exponent now. 2 to the power over root. 10 over 5. So 2 to the 10/5 power. 10/5, of course, will reduce. 10 divided by 5 is 2. So this is 2 squared. And 2 squared is 4. And so my answer is 4, but don't forget, x squared was also part of my answer. I figured out that this part right here was equal to 4, and then I tacked the x squared onto the end of it. So my answer is 4x squared. And so that's how you can use our exponent rules and the idea of taking something that has a fraction exponent, turning it into a root to work it out, and then turning it back into an exponent to get the answer. It's a way that you can do these pretty quickly and pretty simply without having access to a calculator.